So let's start. Yeah, I'm Kunal Soni, as she already mentioned. I work at Hitachi Energy in Basel and did my PhD in plasma physics and nuclear fusion. My talk is going to be about our journey into nuclear energy. So, I like to believe that there have been fewer journeys in science that have been as exciting as our journey into nuclear physics. From the very discovery of an atom in the early 1900s to building the greatest, the most destructive weapons mankind has ever seen, it all happened in a span of 5 decades. And while nuclear energy did become this villain of the emerging society, it still has the potential to solving mankind's greatest problem, clean energy. So let's try to understand how nuclear energy actually works, right? The most common way of harnessing nuclear energy is to split apart big atoms like uranium into smaller atoms, and in doing so, they release a tremendous amount of energy. Yeah, this process is called nuclear fission. And it is this very process that is implemented in all the nuclear reactors around the world that we see today. To be honest, this is the greenest source of energy that we have so far, with the potential to fulfill our energy needs. However, it does have these shortcomings, like the risk of meltdown and like the ones that we saw in Chernobyl and Fukushima, along with other problems like nuclear waste management. However, all is not lost, because there is this another form of nuclear reaction that gives you all the benefits of fission and skips beside all its problems. It's called nuclear fusion. Now, what exactly is this process? This process, quite contrary to fission, involves joining or fusion of smaller atoms into larger ones, and in doing so, they release even more energy than fission. It is this very reaction that powers all the stars in our universe, including our very own sun. Yeah, and it is very clean when I say, because the fuel that goes into producing fusion is essentially just heavier forms of hydrogen, the very same hydrogen that makes up the water that we drink. And the byproduct is a fairly harmless gas, helium. Achieving fusion on Earth, however, is no small feat. You need temperatures of hundreds of millions of degrees Celsius before these atoms can start fusing together on Earth. However, the good news is that is not even the problem. We managed to do that decades back. The biggest challenge in the journey of fusion on Earth so far has not been to start the reaction. It has been to maintain it. You see, fusion as a process already takes up so much energy to start that if you don't maintain this reaction for long enough, you get pretty much nothing out. And the past decades of research have been primarily focused in this area to solve this problem. In fact, in our journey of fusion, we are already so far that we are building the largest experimental fusion reactor in the world as we speak, called ITER, and not too far away from here in the south of France. And with ITER, we might just be able to show that fusion could indeed be used as a source of energy. And if that works, guys, it is quite an exciting time to be alive, because then the day might not be far when our world gets started to light up by these tiny little stars that we build right here on Earth with unlimited clean energy. Thanks a lot, guys.